Okay, 3.3 is about the weighted mean. Actually, the real title of the section is Measures of Central Tendency and Dispersion from Grouped Data. But I'll be honest with you, I'm not going to test or quiz you on the material from this section. The main reason I go over this section is because I think that your life as a student is, it's like you're going to use weighted means a lot. For one thing, the grade that you get in your classes is usually a weighted mean. Um, the GPA, your GPA is also an example of a weighted mean. Okay, so weighted means are pretty useful to you for your life as a student. Okay, so so I just figured it would be good information. So this particular section in the textbook, it covers more ground than just the weighted mean, but the rest of the information is, in my opinion, not terribly important. It's information that you'll see at other points in the semester in ways that make more sense. So I'm just not going to cover it all, but I do want to talk about the weighted mean, so that when it comes to the end of the class and you're like, what do I need to get on the final to pass the class? You don't have to ask me that question. You're statistics students. You should be able to calculate that. If you ask me that question, my answer is going to be, you deserve to fail the class. Because if you can't do it, if you can't figure it out after having taken a statistics class, then you don't deserve to pass statistics. Okay. Anyway, so the weighted mean, here's how it works. So the idea behind the weighted mean is that not all observations are worth the same amount. Like, and you can see why this would be useful for you as a student, because your grade in a class, for example, it's like the test is not going to be worth as much as a homework assignment, right? So, so consequently, we have to compute the means a little different. We can't treat all of your assignments as being of equal worth, because they're not, right? So the way we calculate a weighted mean is we multiply each observation by its weight and then add up the results. And then we divide that by the sum of the weights. Okay? So this is a very scary looking formula, but I promise you it's really not that scary. I'll give you an example. This first example is going to be an example of a GPA. Okay, so GPA is a weighted mean because getting a grade in a 3-unit class is not going to count the same as getting that same grade in a 4 or a 5-unit class, right? So because your classes are worth a different number of units, you have to use a weighted mean to compute your GPA. So this one says, Vanessa just finished her first semester of college. She got a C in her 5-unit biology class, an A in her 3-unit history class, a B in her 3-unit communication class, and a B in her 4-unit math class. What is her grade point average? So you might think, well, this C and this A balance each other and make for a B, and then these two Bs, right? So she probably has a 3.0, but you'd be wrong, okay? Because this C in her 5-unit biology class is weighted more heavily than this A in her 3-unit history class. So she does not have a 3.0. She probably has something slightly less than a 3.0. And let's see what she has exactly at this point. So, so to compute her GPA, we're going to multiply each grade by the number of units, right? The number of units is the weight, right? That's the weight. And the grade is the observation. So the grades, by the way, work like this. An A is worth 4 points, a B is worth 3 points, a C is worth 2 points, a D is worth 1 point, and an F is worth 0 points. So if she got a C, that's worth 2 points. So we're going to multiply the weight of the class, which is 5, times the grade in the class, which is 2, right? So 5 times 2, that's for the biology class. For her history class, we're going to say 3 times 4, right? It's a 3-unit class and she got an A, so 3 times 4. For her communication class, we're going to say 3 times 3, okay? It's a 3-unit class and she got a B. And then for her math class, we're going to say 4 times 3. It's a 4-unit class and she got a B in the class, okay? And then we're going to divide that by the sum of the weights. In this case, the sum of the total number of units that she took. So she had a 5-unit class, a 3-unit class, another 3-unit class, and then a 4-unit class. Okay, this is how her GPA is calculated. So we're going to get 10 plus 12 plus 9 plus 12 divided by 8, 9, 10, 11, 12, 13, 14, 15. Oh, is that right? 8, 9, 10, 11. Yeah, 15. And how much is that? 10 plus 12 plus 9 plus 12 is 43. 43 divided by 15 is approximately, this is about a 2.87. So her GPA is about 2.87, right? It's not a 3.0. Okay. And that's how GPAs are calculated. So if you've ever wondered why your GPA is what it is when you thought it should be, different, well, now you can calculate your GPA, right? And figure out why you're getting what you're getting for your GPA. Okay, here's another example. Okay, it's the end of the semester. The only thing you have left to determine your grade is the final exam. Your average grade in each category of the gradebook is as follows. So here's the category. You have homework, quizzes, tests, a project, and a final exam. And these are the weights, right? Homework and quizzes are worth 15% each. Your first two, each test is worth 20%. So your first two tests together are worth 40%. And then your final exam is 20%. And then your project is 10%. This should look familiar because these are exactly the gradebook weights that you have for your statistics class that you're currently taking, okay? So now let's say these are the average scores that you've earned in each of those gradebook categories. You don't know what your grade is on the final exam because you haven't taken it yet, but you want to know what score you would need to get on the final in order to earn a B in the class, right? Well, to get a B in the class, you need to earn at least an 80%. So here's what we're going to do. We're going to calculate your score in the class. We're just going to call your final grade X, since you don't know what it is, and then we'll solve for X, right? So we're going to say, all right, so I'm going to multiply the weight by the score. Yeah, I'm not going to, you could change them into decimals and stuff. Like as long as you're staying consistent, changing them all to decimals or leaving them all as percentages or whatever, you're fine. I'm just going to leave them as whole numbers. I'm going to say, okay, so my weighted average is going to be the weight times the score plus 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 the weight times the score, which we don't know. Okay, and then we're going to divide by the sum of the weights. And we're going to say, okay, so this has to be at least 80%. If you want a B in the class, you need to have at least 80%. And then solve this thing for X, okay? So let's see what we get. Oh, this should be 100, right? 15 plus 15 plus 40 plus 10 plus 20 is 100. Yep. Okay. So, all right, if I want to solve for X, the next thing I would probably do is multiply both sides by 100 to clear that fraction. And then I can also combine all of these like terms, right? I can add those all up. So 1305 plus 1080 plus 3160 plus 950 is 6495 plus 20x needs to be bigger than or equal to, if I multiply both sides by 100 to clear the fraction, then it needs to be bigger than or equal to 8,000, right? Now to finish solving for x, I would subtract 6495 over. And then I would divide by 20, right? And x would be bigger than or equal to 75.25. So what grade does this student need to get on the final in order to get a B in the class? Well, they need a 75.25%. As long as they get at least a 75.25%, they'll get a B in the class. Okay, well, so we could ask all kinds of follow-up questions like, okay, so I only need a 75 in order to get a B. Is it possible for me to get an A? Could I get an A possibly? Well, to answer that question, you would do all the same work, only instead of an 80 here, you would have a 90, right? So you change this to a 90, a 90. That makes this a 9,000 instead of an 8,000. And that would make this a 2505 instead of a 1505. And let's see now, 2505 divided by 20 is 125.25. So to get an A, you would need, so to get an A, you need a 125.25% on the final. So is it possible for you to get an A? No, right? It's not possible to score that much. The best you can do is 100%, right? So no, not possible. Okay. Part C asks, what would your final grade in the class be if you didn't show up for the final exam? Right? Because a lot of times students say, oh, I only need a 75 on the final, so I can just blow this final off. And then they don't even show up to take the final exam. And guess what happens? They fail the class because the final is still worth 20% of your grade. You can't just not show up, right? What would your final grade in the class be if you didn't show up? Well, it would be this expression up here, but replace the x here with a 0, okay? So basically, it would be the 15 times 87 plus 15 times 72 and so forth, but without the 20x. So it would be 6495 divided by 100, right? It would be 6490. I'm really just kind of skipping a lot of work here, but it'd be 6495 divided by 100. In other words, 64.95%, not passing, not passing. So don't blow off your final exam completely, but yeah, as long as you show up and do decently well, you're going to get a B. So that's the idea there. This was like, oh man, I just finished grading finals for the spring semester. And this was the case on so many students. It's like I had students who were, doing fairly well, and then they just completely blew off the final exam. And it was enough to bring their grade to like a 67%. And now they're all emailing me asking me, is there anything I can do to bring my grade up? No, what you could do is go back in time 2 weeks and study more for your test, right? I mean, like, no, the answer is no, not at that point. So anyway, don't blow it off. So that's that. I'll just give you one more example. This is an example from something from the quote unquote real world. Although you would probably never compute the average this way. But anyway, I think this is a good example to show you why the formula for the weighted mean works, okay? So this one says, suppose a company owns 3 cars that get 20 miles per gallon, 2 cars that get 22 miles per gallon, and 1 car that gets 24 miles per gallon. What would the mean miles per gallon be? So if you're thinking, well, it would just be 20 plus 22 plus 24 divided by 3, then you're wrong. Because there were 3 cars that got 20 miles per gallon and only 1 car that got 24 miles per gallon. So the 24 miles per gallon is weighted less heavily than the 20 miles per gallon is. So we would use a weighted mean to compute this. We would say, all right, so the weighted mean, is going to be 20 times 3, because there were 3 cars that got 20 miles per gallon, plus 22 times 2, because there were 2 cars that got 22 miles per gallon, plus 24 times 1, because there was 1 car that got 24 miles per gallon. And now you're going to divide by the weights, 3 plus 2 plus 1. That ends up being, 60 plus 44 plus 24 divided by 6, which is 60 plus 44 plus 24 divided by 6 is about 21.3. So I'm going to say it's about 21.3. Okay. Another way you could have done the same problem is to realize that, okay, if there are 3 cars that get 20 miles per gallon, then I could just say 20 plus 20 plus 20. And then 2 cars got 22 miles per gallon, so 22 plus 22. And then 1 car got 24 miles per gallon, so 20 plus 24. And then I'm going to divide by the total number of cars. There are 3 cars, and then 2 more is 5, and then 1 more is 6. Right? You're going to get the same answer, right? You're going to get X bar is approximately 21.3. And hopefully you can see the connection here between these two things, right? Saying 20 plus 20 plus 20 is the same as saying 20 times 3. And saying 22 plus 22 is the same as saying 22 times 2. Right? And saying 24 is the same as saying 24 times 1. So hopefully this example illustrates why the weighted mean formula works, okay? But that's that. Just three homework problems for this section. I am assigning you an even problem from this section. So I'm giving you the answer here so that you can check your work, okay? You should get 87.15% on number 10.